All right, in this video, we want to find the inflection points and the intervals of concave up and concave down for these questions over here. So one thing that's important to note is that in the two questions I'm doing in this video, there are no vertical asymptotes in either of the two questions. So I'm not going to bother explaining the steps that involve questions with vertical asymptotes, which is slightly more complex. So if I want to find my inflection points over here, just need to find the x values. I need to find the second derivative. So before I can derive this the first time, I want to just simplify it to 6x squared plus 2 to the exponent of negative 1. Then I can just derive this using my chain rule. Oops, there's no prime there. So f prime x equals negative 6x squared plus 2. My new exponent is negative 2. Then by the chain rule, I'm multiplying by the derivation of the inside, which is just 12x. I can simplify this a bit, so I can rewrite this as negative 12x divided by 6x squared plus 2 to the power of positive 2. That's my first derivation right there. Let me go to my second derivation in this question. F double prime x. In order to derive this a second time here, I have to use my quotient rule. So in order to do my quotient rule, f is negative 12x, the function on the top. G is 6x squared plus 2 squared, the function on the bottom. F prime is just negative 12. G prime is 2 times 6x squared plus 2. And then times the multiple, the new exponent is just 1. And then over there, it's just times the derivation of the inside, which is 12x. You can simplify to 24x times 6x squared plus 2. So now let's put this in my quotient rule. So f prime times g minus, and this minus here will make it plus. So I'm just going to write the plus right now. 24 times 12 is 288, I believe. X times x is x squared. I have 6x squared plus 2. F prime g minus g prime f divided by g squared. So if I square this square, will become a new exponent of 4. Next thing I want to do is I just want to simplify this equation a bit. I'm going to common factor out over here. I can common factor out a negative 12, and I can also common factor out 6x plus 2. And if I do that over here, I'm just left with 6x plus 2. And over here, the 6x plus 2 disappears. 288 divided by negative 12 is just negative 24. Just did that calculation a bit earlier, and then I have an x squared there. And then the denominator is just the same for now. I can simplify this a bit further. You can cancel this and make this a cube, and I can combine like terms inside the bracket. Oops, I forgot to write my square here on the previous step. I forgot to write it here as well, but those are both squares. So if I combine like terms here, I will get negative 18x squared plus 2. Denominator is just 6x squared plus 2 cubed. So now I can make this equal to 0 and solve for the inflection points. So I can start by just cross multiplying the denominator, which will just disappear. And divide both sides by negative 12, which will basically cause that to disappear as well. Move this to the other side to make it positive. oops, equals 2. Divide both sides by 18. X squared equals 1 over 9, and I can square root both sides. So x just equals, the inflection points are just positive or negative 1 over 3. So 2 inflection points in this question. I don't need to find the y values, just the x values. So those are my 2 inflection points. Now I need to find the intervals of concave up and concave down. So I'm going to start by just putting my inflection points on a number line. No need to do vertical asymptotes because there are no vertical asymptotes in this question. And I want to test these 3 ranges over here. And I want to test them in this equation right over here. The first point I'll test is -1. If I solve a -1 into this equation, -1 squared is +1. 1 times -18 is -18, plus 2 is -16. -16 times -12 is positive. So we have a positive on the numerator, and -1 squared is +1 times 6 is 6, plus 2 is 8. 8 cubed is a positive value. I have a positive divided by a positive, which is just a positive. And if it's positive, it means that the function is concave up in this interval. So here I'll pick 0 as my value. If I pick 0, this is all going to be 0. So I have -12 times +2, which is a negative in the top. In the bottom, if I sub 0 here, I just have 2 cubed, which is positive. Negative divided by positive is negative. If it's my f double prime x is negative, it means it's concave down in this interval. Then over here, I'll pick +1. +1 and -1 give me the exact same answer in this question because the x's are both squared, which means +1, -1 will give me the exact same answer of negative divided by positive, which is, oh, sorry, positive divided by positive, which is positive, means this is a concave up interval. My intervals of concave up are from negative infinity to -1 over 3 and 1 over 3 till positive infinity. 2 intervals of concave up. My intervals of concave down are just from -1 over 3 till positive 1 over 3. Let's go to the second question over here. It's on another sheet. And same idea in this question, but we also have to find the critical points. So critical points, inflection points, and then intervals of concave up and concave down. Let's start with finding our critical points, which means we need to find the first derivative over here in this question. To derive this, I need to use my quotient rule, but before I derive it, I can simplify it. I can actually just divide everything by 5. It will make my life a lot easier. So I'm going to start by doing that, and then I'm going to do my quotient rule for this question. So f equals to e to the x, g equals to e to the x plus 1. F prime is e to the x, g prime is also e to the x. And now I want to put this in my quotient rule. F prime x equals f prime times g minus g prime times f divided by g squared. Now I want to simplify the top. There's nothing I can really factor out. I could factor out an e to the x if I wanted to. But I'm not going to do that because I can just simplify this technically. Actually, I will factor it out. Why not? It's the same steps. I'm going to common factor out an e to the x. If I do that, I'm just left with e to the x plus 1 minus e to the x, and then denominator just stays the exact same. And then what I can do is I can cancel these two out. So I just have e to the x times 1, which is just e to the x, and the bottom is just e to the x plus 1. squared. So now that I found my derivative, I can make it equal to 0 and solve for the critical points. So I'll start by cross multiplying this over. So I get 0 equals to e to the x, but an e equation can never equal to 0 because e equations are always, a regular e equation is always above 0, which means there's no critical points in this question. So let's go to the inflection points next. To find the inflection points, I need to do my second derivative. This is my first derivative over here in the most simplified form, which I'm going to derive a second time, which means that I'm using my quotient rule again. F equals to e to the x and g equals to e to the x plus 1 squared. This one's a bit more complicated. F prime is e to the x, g prime is 2, e to the x plus 1, new exponent is 1, and then my chain rule means it's times e to the x. So this is just 2 e to the x times e to the x plus 1. And put this in my quotient rule now. So f double prime x equals to f prime times g minus g prime times f. So that's 2 e to the x. I'm gonna put the e to the x twice. You could have also probably written as 2 e to the x, but I'm just gonna leave it like that. F prime g minus g prime f. I just multiplied those two. Divided by g squared. So this is going to be e to the x plus 1, and my new exponent is going to be 4. Now I want to simplify this. I can common factor out an e to the x. I can also common factor out e to the x plus 1. And if I do that, I'm left with, over here, I'm just left with e to the x plus 1. And over here, I'm just left with minus 2 e to the x. This gets taken out, this gets taken out. Denominator just stays the same, e to the x plus 1 to the power of 4. I can cancel this and turn this into a 3, and I can combine like terms in here. So this is going to be e to the x. This is going to be 1 minus e to the x. Denominator is just e to the x plus 1 cubed. That's the simplified form of my second derivation. I want to make it equal to 0 and solve it. I'll start by just cross multiplying this over. Means I just have 0 equals e to the x times 1 minus e to the x. Now e to the x can never equal to 0, so this one has no solution. But 1 minus e to the x can equal to 0. I'm going to solve that separately. 1 minus e to the x equals to 0, which means that I can move this to the other side. So 1 equals to e to the x. I can move the e to the other side and turn it into a ln. So ln of 1 equals to x. Ln of 1, and you should know this without a calculator, is just a 0, which means my inflection point is x equals to 0. I only have a 1 inflection point in this question. So now what I want to do is I want to do my number line. On my number line, I want to put 0 over here. Only inflection point, there's no vertical asymptotes, and I want to find my intervals of concave up and concave down. So I'm going to sub in values into my simplified form of my derived equation. Start with subbing -1 into this equation. E to the -1 is positive value. E to every value is positive. This is always positive no matter what. This is a positive value. E to the -1, though, we know it is less than 1, right? Because e to the 0 is 1, which means e to any negative value is less than 1, but greater than 0. And e to any positive value is bigger than 1. So 1 minus a decimal will still be positive. So we have a positive times a positive. and then divided by another positive here, because here the negative one is positive, plus one is positive, cubed is positive. So positive, positive, positive means this is going to be concave up. Second derivative is positive. Next, I'll sub in positive 1 into this equation. So I sub in positive 1 into this equation, I will get e to the 1 is positive, e to the 1 is positive, e to the 1 is definitely above 1 as well. E to the 1 is like 2.7, but you know it's definitely above 1. So 1 minus a value above 1 is a negative value. Denominator is also going to be positive, because e to the 1 plus 1 is positive, cubed is positive. So I have positive, negative, positive, which means this whole thing is going to be negative, which means this is concave down. So my intervals of concave up are from negative infinity till 0, and my intervals of concave down are from 0 to positive infinity. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.